Hello, and welcome to Option Pricing in Greeks 101 on Bloomberg. You can see the three questions in front of you, which we're going to answer today using the Bloomberg function. You should have your own copy of these three questions. Depending on your starting point of the Bloomberg page, you can always type the word Apple to bring in the security. So we now have the Apple security loaded, you see. And now we're going to write the word option, and the autocomplete will suggest a function called OVME, the option valuation for equity. That is the function I require. I now have Apple underline loaded, ready to price options in Apple. Now, question 1 says, what is the price of a call that has a strike of 100 with 365 days to expiry when a dividend yield is 0. Now, in the real world, Apple does have a dividend yield, but for the sake of the question, the dividend yield is 0, and the interest rates are 2%. So I'm going to overwrite the current interest rates and put 2%. Additionally, the underlying is 100. Now, whenever you price an option can't be priced in isolation of where the underlying is. That is a very important input as well. So I have an input of $100 for the underlying price. It is a call. It is a 100 strike. There are 365 days to expiry. Interest rates are 2%. Dividend yield is 0. And my forecast for volatility, part A, is 20%. That gives me an option price of $8.91. That's part A answered. Now notice, in the listed options markets, options are vanilla style. If it's not vanilla, it's exotic. That would be, for example, a knock-in, knock-out option, or a digital, or a one-touch. Those are examples of the non-vanilla options. But in the listed options market, they are vanilla options. The exercise style for equity options is American, which means they can be exercised at any time. Buying and selling an option is a separate procedure to exercising the option. The opposite to an American style is a European style option. Normally, stock index options are European style, which means they can only be exercised at expiry. The other thing about listed options is the number of shares is normally 100. So each options contract in a listed option would be worth 100 shares. So per share, the option would be $8.91, but to buy the whole contract, it would cost you $891. Okay? Now I'm just going to put that back as a 1 multiplier for the moment. There is also a rule of thumb that when clients deal with over-the-counter options, strictly over-the-counter options, they tend to leave the multiplier as 1 share per contract. This is a differentiator between listed and OTC. Now, there is, of course, a hybrid in the middle. Sometimes clients will deal in flex options or listed lookalikes, and those listed lookalikes would have a 100 share multiplier. For the moment, I've left it as 1. Part B, your forecast of future volatility is 21%. So I'm going to enter 21 in here. What's the 8.91 as I press enter? It becomes 9.3. So it went from $8.91 to $9.30 a share when the when the forecasted volatility, not the implied, that's a different thing altogether, when the forecasted volatility went from 20 to 21. Part C, which Greek describes the difference in these prices? The Greek, of course, is the Vega. V for volatility, V for Vega. So at 20%, the Vega was 0.39. That means that 39 cents are going to be added onto this option price as we go up 1 vol point. And that's what you saw. Okay, that is question 1, parts A, B, and C answered. Question 2, the underline is still 100. This time the strike is 102. Forecasted volatility of 20%. This time the rate is 1, dividend yield is still 0, and now there are only 5 days till option expiry. This gives me an option price of just 28 cents. That's what the option would be worth. That is 5 days. That's part A answered. Part B, I changed this to 4 days, and that drops down to 21 cents. Okay? Part C, which Greek describes the difference in these prices, T for time, T for theta. This rate here is the decay due to the passage of time. So if this were a 5-day option, the theta is 7 cents. So you take 7 cents off this price. As 1 day goes by, 7 cents off 28 gets me down to 21. So that's proved that the theta is there for the time decay. Now, bonus question. Why was a 365-day option chosen for question 1 and not a 5-day option? Well, let's put this back to 365. Let's put that strike back to 100. Let's put this rate back to 2%. So this 365-day option has a Vega of 39 cents. So the absolute number of cents change of a options price is much bigger than for a 5-day option, 102 strike with interest rate 1%. That Vega is as low as 3 cents. So in terms of absolute numbers, the Vega is much bigger. It will change the option price by more dollars when there is a lot more time left on the option price. So the sensitivity to changes in forecast of volatility is much bigger for a longer dated option. Part B, why was a 5-day option chosen for question 2? Question 2, you remember, was looking at theta. Well, here, my theta is 7 cents for that 5-day option. When I look at that 365-day option, 100 strike, 2% rates, that theta is only 1 cent. So the time decay is much, much bigger in a short-dated option. You may remember the graph of the time decay, which essentially is a parabola on its side, and for the first 2/3, maybe 3/4 of an option's life, the time decay is very small, but as you get to the last 1/3, 1/4 of an option's life, the time decay accelerates, or the option value deteriorates very quickly, depending which way around you're looking at the graph. Question 3, part C, why was a 2% out of the money chosen for question 3 and not, say, a 10 or a 15% out of the money option? Well, the reason for this is when you have such a short-dated option, being 2% away from the strike, the option still has a value. But if we were 10% away from the strike, such as 110, notice there would be no optionality left. That option would be virtually worthless. There, that's answered the 3 questions. Thank you, and tune in for Options Pricing in Greeks 102. Thank you.